Hi everyone, welcome back to part 2 of 8.4, and we're going to be picking up here with more volume problems for the prisms and pyramids that we talked about in the last video. So take a second, pause the video, and read the next example, and then you can unpause it when you're ready to watch. It says Frank's fish tank is in the shape of a hexagonal prism. Use the dimensions shown in the figure and the fact that 1 gallon equals 231 cubic inches to A, determine the volume of the fish tank in cubic inches, and B, determine the volume of the fish tank in gallons. We want to round our answer to the nearest gallon. So the first thing we need to do is find the volume. And we know that the general formula is volume equals big B times the height. Remember that big B stands for the area of the base. And the base is it's made up of a hexagon, but as you can see, if we divide the hexagon in half, we end up with 2 trapezoids. So there is a formula to find the area of a hexagon, but you need trigonometry to do that. So instead, we'll work around that, and we're going to find the area of the trapezoid and then just double it to get the area of the hexagon. And that'll give us the area of the base. So to find big B, right, we have a trapezoid, and the area of a trapezoid formula, if you'll remember, is 1/2 times the height times base 1 plus base 2. So if I'm looking at the trapezoid, okay, just one of them, as you can see here, the height of the trapezoid is 8 inches. And my bases would be this side and this side. So as you can see, this is the same as this. So we know that base 1 is 16. And the other base is going to be this length, which we know is 8. And it doesn't matter which one is your base 1 or your base 2. So half of 8 is 4. 16 plus 8 is 24, and 24 times 4 is 96. So I know that the one trapezoid, the yellow one, is 96. I need the area of the hexagon to get the area of the base. So it's made up of 2 trapezoids, so all I'm going to do is I'm going to double 2 times 96, and that's going to give me the area of the trapezoid, which is the area of the base, or big B. So 2 times 96 gives us 192. And of course, its area, it's inches squared. So now to get the volume, we have everything we need. We've got the area of the base, which is 192. And then we're going to multiply by the height of the prism. So the height of the prism is the height when the prism is sitting on its base, and it is. So my height is 24. And then if you multiply 192 times 24, you'll get 4,608 inches squared, inches cubed. So that would be my volume. Okay, that's how much water would fit in that tank if you were to fill it all the way to the top. Okay, so question A asked us to determine the volume of the fish tank in cubic inches, which we did. In part B, we need to determine the volume of the fish tank in gallons. So they gave us a conversion. 1 gallon is 231 inches cubed. So I know that I have 4,608 inches cubed. So to figure out how many gallons that is, I'm going to take 4,608 inches cubed, and I'm going to multiply that by my conversion. 1 gallon equals 231 inches cubed. Remember, I want gallons, so I want inches cubed to cancel. That means it needs to go in the denominator. So I know 1 gallon is 231 inches cubed. So the inches cubes are going to cancel. And all this really is 4,608 divided by 231. And that's going to give me 19.95 gallons. And we need to round to the nearest gallon. So that 9 makes the 9 here go up 1. So it's about 20 gallons, which is a big fish tank. So if you'll remember, prisms have two bases and their faces are parallelograms. Okay, so as you can see here, here's a base at the top, here's a base at the bottom. There's your two bases, and the faces are all parallelograms. Okay, rectangles are a type of parallelogram. So you also name a prism by the shape of its base. So since the base is a hexagon, it's 6 sides, we would just call it a hexagonal prism. But now we're going to look at pyramids. So a pyramid, if you'll remember from our last lecture, a pyramid has one base and its faces are triangular. Okay, we also call them the lateral faces. So as you can see here, this has one base, this has one base. They all have one base. They all come to a point because all of the lateral faces are triangles. Okay, so to name these, again, you would name them according to the shape of the base. So the base here is a triangle, so I would just call this a triangular pyramid. And then this shape here, the base is a square, so you would call this a square pyramid. And then this one here, the base is a hexagon, so we would call this a hexagonal pyramid. And then the base in letter D looks like it's a rectangle, so we would just call this a rectangular pyramid. Okay, so I want you to take a look at the next diagram, and it's a pyramid, okay, and this would be a square pyramid, and I know this because a square has all equal sides and all equal angles. All the angles are right angles. So since this side is 5 and that side's 5, I know that this is a square because the side opposite would be 5 and the side opposite this would be 5. So I have a square pyramid. Okay, and I need to determine the volume. So for pyramids, it's 1/3 the area of the base times the height. So all we're basically doing is what we did for prisms, but at the end you're going to divide your answer by 3. Okay, so remember, big B again stands for the area of the base. So my base here is a square. Okay, how do I find the area of a square? If you'll remember, the formula is side squared. You can also use length times width. You'll still get the same answer. But since all the sides are the same, we just take the side and square it. So remember, 5 squared is 5 times 5, or 25. So the area of the base is 25 meters squared. The height of that pyramid is 6 meters. So all I need to do now to find the volume is just 1/3 times 25 times 6. So you could, if you wanted to, multiply 25 times 6 together, and you get 150. And then divide that by 3, and you get 50 meters cubed. Okay, in the last set of examples, we're going to look at unit conversions again, okay, which is important because our labels are not always going to be the same. We might have to convert from inches, cubic inches to cubic yards and so on, or cubic yards to cubic feet. So, for example, let's say you're purchasing topsoil, you might have to change the amount from cubic feet to cubic yards prior to placing your order. So you would need to know how to do that. So if you'll recall, in lesson 8.3, we did some conversions, okay, and 3 feet is equal to a yard. So if I want to convert from yards to feet or feet to yards, I need to remember that. Now, let's say I want to convert from cubic yards to feet. So cube means to raise it to the third. So all I'm going to do is raise each side to the third power. And 3 to the third, remember, just means 3 times 3 times 3. So that's 27 feet cubed equals 1 cubic yard. So if you can remember that conversion, you can convert from cubic yards to cubic feet and vice versa. So let's say I want to convert here 1 cubic yard to cubic feet. I already have the answer right here. Okay, so we know now that 1 cubic yard is equal to 27 cubic feet. But we're going to use that now to determine this other conversion. So in number 2, we have to convert from cubic feet to cubic yards. So I'm going to do a method called dimensional analysis that I used in 8.3. And what we do for that is just multiply by fractions, and our fractions contain our conversions. And the goal is just to cancel out what you don't want. So I don't want cubic feet anymore. I need to convert to cubic yards. So what I need to do is cancel this feet cubed out. I'm going to do what I did in the fish tank problem where I converted to gallons. Remember, I needed to get rid of inches cubed. So I needed to have them diagonal from each other to cancel them. So I'm going to do the same thing. I'm going to take my conversion, which I know is 1 cubic yard is equal to 27 cubic feet, and I'm going to make sure the feet cubed is diagonal from the other feet cubed, and then I have 1 cubic yard on top. So by doing that, the cubic feet will cancel, and now you're just left with 843.75 divided by 27. And when you divide those, you get 31.25 cubic yards. For the next one, I'd like you to pause the video and try doing it on your own, and then you can unpause when you're ready to go over it. So here we're going backwards. We're converting from 5.7 cubic yards to cubic feet. So now I need the cubic yards to cancel. So I'm going to take my same conversion. I know 27 cubic feet equals 1 cubic yard, but this time I want the cubic yards to be diagonal from each other. So now I'm just going to basically take the fraction I used in the above example and just flip it over. So I'm doing the reciprocal. And the cubic yards are going to cancel now. And now you would be multiplying 5.7 times 27. And you'll be left with cubic feet. So when you multiply 5.7 times 27, you get 153.9 cubic feet. Okay, feel free to pause the video for the next problem as well. Read through the problem and use our problem-solving strategies that we've been discussing to answer the question. Carlos recently purchased a home with a rectangular swimming pool. The pool is 30 feet long and 15 feet wide, and it has a uniform depth of 4.5 feet. Carlos plans to fill the pool in with dirt to make a flower garden. How many cubic yards of dirt will Carlos have to purchase to fill in the swimming pool? So let's highlight what's important here. I know that we have the rectangular swimming pool, and the dimensions are 30 feet long, 15 feet wide, and it says it has a uniform depth of 4.5 feet. Uniform means it just stays the same, it's flat. So the depth stays constantly 4.5, it's not changing. Okay, Carlos wants to fill in the pool, so we know that's volume because we're filling in a three-dimensional figure. And the question says, how many cubic yards of dirt will Carlos have to purchase to fill in the swimming pool? So a couple things. We're looking for cubic yards, and your indication, when you see cubic yards, you know you're looking for volume. Just like if you see square yards, you're looking for area. Okay? The other thing that's important is this is in yards, but all of our dimensions are in feet. So we're going to have to convert in the end. Okay, so if you have a rectangular swimming pool, think about the shape of that. And that would look like this figure here, something like this. Okay, it would be more so a rectangular prism, or even better, something like that. Okay, so how do we find the volume of a rectangular prism? If you'll remember, volume is always area of the base times the height. And if we're dealing with a rectangle, and it's a prism, the area of a rectangle is length times width. So it's just going to be length times width times height. And height here is depth. So we're just going to multiply 30 times 15 times 4.5. And when you multiply all that out, you get 2,025. Remember, your dimensions are in feet, so feet cubed. I need to figure out cubic yards. So I need to remember my conversion. And if you'll remember, 1 cubic yard is equal to 27 cubic feet. Okay, so we're going to convert 2,025 cubic feet to cubic yards. So where would I have to put the 1 cubic yard? It would go on the top because, again, you want the cubic feet to cancel. So you would want cubic feet on the bottom so it's diagonal from the other cubic feet so you can cancel them out. So the cubic feet will cancel out. And now all you're going to do is get 2,025, and you're going to divide that by 27. And I was wondering why my pen's not working. 2,025 divided by 27. And when you divide them, you should get 75 cubic yards. Okay, and that wraps up the 8.4 lesson. So please make sure you're working on the homework. If you have any questions, please reach out. And also make sure you take time to do the study guide in preparation for test number 3. Okay, hope you all have a great rest of your day.